So on page 259 of your student journal, we start out with the tangent ratio. So the first of the three trig ratios that we will cover. All right. At the top of the page, you see there's some info about trig ratio, defining it, tangent, angle of elevation. You could also add in there, maybe right next to angle of elevation, another thing to define, angle of depression. Okay, and those two I just want to touch on really quick. As we're dealing with angle of elevation and angle of depression, it's important to remember that you need a horizontal line. Okay, always start with a horizontal.
Does it say angle of depression?
Yes. Yeah, angle of depression. So when you're dealing with angle of elevation or depression, start with that horizontal line. All right? If from that horizontal line you go upward, that is an angle of elevation. So if your line starts going up, that's an angle of elevation. If from that line you go down, that is an angle of depression. All right. Key piece, because when you're dealing with story problems and trig ratios or real life examples, they'll reference angle of elevation from a point to another point, and you have to be able to recognize that you have to find the horizontal line you're dealing with first. If you can't find it, you need to draw it in and then depress or elevate from that horizontal. That'll become more evident when we go through some of these problems. But all right, the trig ratios, the key piece to start out with, you need to write down the phrase so ka toa. Sokatoa. 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 All right. Now Sokatoa has some abbreviations that will help you out. Now, when I'm dealing with a right triangle, which is what you're dealing with when you're dealing with the trig ratios, this is right triangle trigonometry. Okay? When you're dealing with the right triangle, you have three different sides. You have a hypotenuse, which is always your longest side. You have an angle that we will call theta. Okay, so theta could be an angle they give you. Okay, and I use theta because that's what you'll use. I don't know how much you'll use it in this year, but you use it a lot next year. This is just theta just means an angle measure, like a degree measure. Okay? So they give you an angle, and then from that angle, there is a side that is adjacent to that angle and a side that is opposite. Okay? What I tell students to do is I say, well, if you're trying to find the opposite side, you should really trace the angle they give you, or the angle you're looking for. So when I trace it, notice when I trace that, there is a side that I have not traced over. Everyone see that side? That side that I do not trace over is called the opposite side. I guess I should spell these out since this is the first time we're using hypotenuse, opposite. The side that you did trace over is called the adjacent side. It is key for you to get those pieces together. Okay? And one of the hardest things that some students have at the very beginning, one of those sticking points, is figuring out which one's opposite, which one's adjacent. If you keep talking to me, I'll say trace the angle. Okay, it's that one's the opposite. All right. Now, each one of these represents a trig function. S stands for sine. C stands for cosine. And T stands for tangent. Okay? O stands for opposite. H stands for A stands for SOHCAHTOA. What this does, this actually gives you the three trig ratios. A ratio means a fraction. Okay, this is saying sine is equal to the opposite over the hypotenuse. This is saying cosine is equal to the adjacent over the hypotenuse. And this is saying tangent is equal to the opposite over the adjacent. Okay, now I've seen it written out like that. I probably prefer the method where you actually have it kind of set up like that. Okay, SOHCAHTOA. Okay, it shows your ratios. So what I would do anytime I'm dealing with sine, cosine, and tangent is set up those three ratios. Write out SOHCAHTOA on top of my paper. Well, today we're dealing with the tangent ratio. Opposite over adjacent. Tomorrow we will be dealing with sine and cosine. Okay? Questions? All right, here we go. Let's go ahead and turn the page. That is the exact same page. I don't know where I got that. All right, page 260 of your student journal. Find the tangents of the acute angle in the right triangle. Write each answer as a fraction and as a decimal, rounded to 4 places. Okay, try number 1 on your own. Actually, you can work with a group. Try number 1. Okay, let's see if we understand what's being expected here. So the acute angles, what are my acute angles? R and S, right? So if I'm doing the tangent of R is equal to the opposite over the adjacent. So if I am tracing R, that's that angle. This is opposite, that's adjacent. That's the first thing you need to do is be able to label those. Trace your angle. Okay, obviously my angle tracing needs a little extra work. But, okay, if I'm dealing with opposite of R is 45. Adjacent of R is 24. Okay, there's fraction form. Tangent R is equal to 45/24. Decimal form, if I round to 4 decimal places, is 1.875. That's 3 decimals. And if there's no more, you put the 0 on. Yep, 4 decimals. Good. All right, if I am going the tangent of S, notice when I trace the other angle, the angle S, the side that was opposite is now adjacent, and the side that was adjacent is now opposite. Okay, so they switch. We get tan of S is equal to 24/45, opposite over adjacent, which is that greater than or less than 1? Less than. How do you know without putting it into your calculator?
Because the number on top is less than the bottom.
Good. Key piece. The number on top is less than the bottom one. Okay, that may seem obvious. I hope it is, but that's a key piece when you start dealing with sine, cosine, and tangent. Okay. Questions on those? Yeah. Which adjacent side I pick? It does. It depends upon the angle that you trace. So when I'm talking about angle S, I've got to trace angle S. This one's adjacent. This is the hypotenuse, right? Okay, so you can't use that. Is that what you meant? Okay. Yeah. Yeah, that's the hypotenuse, so we can't use that one. Good question. Okay. Very good. Okay. Moving on, I want you to try number 4. Find the value of x, round your answer to the nearest 10. Okay, nearest 10. Number 4. Work with your groupie there. Set up your ratio first. Hypotenuse is always your long. Okay, so in this triangle, I am tracing this angle, the angle they give me. Now, reality is you could find the other acute angle if you wanted, but they give you that one's 10. So if I trace that, the side I didn't trace is opposite. The other leg that I traced is adjacent. The longest side is the hypotenuse. So if I'm dealing with this, I'm looking for the adjacent. I'm given the opposite. I'm using the tan function. The tan of my angle, 10, is equal to the opposite over the adjacent. Oh, I guess A is actually x. Let's use x. How do I solve that? What's that? Yeah.
If you put 10 over 1 and then multiply 5 by 1 and divide by 10.
Yeah, well, you definitely cross multiply there. So you get x tan 10 is equal to 5. Now let's be clear that tan 10, tangent of 10 represents a numeric value. Everyone figure out what tangent of 10 is. Take your calculator, figure it out. It's tangent of 10. Okay, now some of you are going to get different values. Okay, so if you, on your calculator, you should push the tangent button. Find the one that says tan. And 10. And we've got enter. Now, did anyone get something different? Okay, all you guys walking around, have a seat for now. Wait until I'm done talking, then you can go. Okay? Who got something different? All right, let's see. How many of you got... How many got that? Okay, that means your calculator is in the wrong mode. It is measuring in radians and not degrees. So go to mode. Okay, so mode is right here. Click on mode. And now go down to where it says radian degree and select degree. And then quit. And now when you do it, you get that. That is the numeric value of tangent of 10. It is an irrational number that keeps going on forever. Okay? You guys good? All right. Of 10. It is a numeric value. Make sure you're in degrees. And I'll tell your neighbor how you know to be in degree and not radian. It has nothing to do with mode. How do you know you're in degrees and not radians with this problem? Yeah. Everyone hear Sam's question or answer? Question answer? I'm not sure. What'd you say? Yeah, because the angle says 10 degrees. Now some of you are like, well, okay. Well, eventually in advanced algebra, all you're dealing with, and pre-calculus, calculus, you start dealing with radians. So how do you know you should be in degrees or radians? Well, look at what they give you. Is it that simple? Yeah, usually it's that simple. If they give you degrees, you're in degrees. If they give you radians, you're in radians. How do I know if I'm in radians? They'll have something like pi over 2. Pi. 4/3. 4/3 pi radians or something like that. Okay? Then you're in radians. Right now we're in degrees. This year, we are going to primarily be in degrees all the time. Now, Trig, the other students who use our graphing calculators, will be in radians most of the time. Therefore, if you're using a classroom calculator, the first thing you should do is check. Yeah, make sure your mode's in the correct mode. Make sure you're in degrees, not radians. If you're getting all the wrong answers or your friends like mine doesn't match up, check your check your mode. If you have a friend that thinks it's funny to switch your calculator around just for fun, like, haha, watch this. They like switch your mode. I had a student do that to another student last year right before their quiz. It wasn't too funny for him. Okay. I know. What a friend, right? Just Josh? I'm just joking you, man. Come on. Dude. That's not a very nice joke. Okay? If you have one of those friends, maybe check your calculator every once in a while. All right. How do I solve from here? If I had the value 4x equals 17 and I wanted you to round that to the nearest tenth, what would you do to solve?
Divide by 4.
Yeah, you divide everything by the numeric value of 4. And then you would round. Well, here, if I'm saying solve for x and round to the nearest tenth, I am dividing everything by the numeric value attached to x. The numeric value attached to x is tan 10. Now you do not round this. You keep it as tan 10 and divide both sides by tan 10. You get x is approximately, and that's where you actually put in 5 divided by tan 10. 28.4. All right.
Why don't you have to round it to 4 decimal places?
Because it says round to the nearest 10. Yeah. Have we had the discussion about rounding here? It becomes key, especially when you guys taking online, doing online assignments, online quizzes. We've had that discussion. Okay, so if it says tenth, I want you to think of the number 10. How many zeros are in it? 1. That means it's 1 decimal place. If it says hundredth, I want you to think of the number 100. How many zeros? That's 2 decimal places. If it says thousandth, how many zeros? 3. That's 3 decimal places. If it says 10,000, how many zeros? That's 4 decimal places. Do we get that? Okay, make sure that we're clear on that. That's really how you do your rounding. So you always look at the number behind that value. So here it was 0.35, so that rounded up to a 4. Okay? Right? 28.35. I don't want to assume everyone knows rounding, even though we should all know rounding. Okay, we're rounding the 3, we're rounding that place, we look at the 5, it goes up to 4. If it's 5 or higher, we move up. All right. Very good. I want everyone to try number 5, please. Yeah. Okay, 13 tan 64. We get 26.7. Anyone else get 26.7? Yeah. All right. Hey, notice I put tan 64 in parentheses. You don't have to. It just helps me remember that that's a numeric value. So this is 13 times that, 1 times that. Now I'll start seeing some students start doing shortcuts. They're like, I'm like so good, I don't even need to write this stuff out. You're like so good, you're going to miss all the points on your assignment, in your quiz. Make sure you write out the setup, please. Okay? That'll help you out. Not to mention when you get to law sines, law and cosines, that'll help you out quite a bit there too. Okay, any questions? Woohoo! I want you guys to try number 7. Number 7. Those of you struggling, you're like, huh? Draw the picture. Start by drawing a picture. sound like a sigh of relief. Like this is the best. Okay, if we got CDE, what's this? This is E. How do we know that's E? Right? Okay. Tan C is 4/3. Well, that means if this is, for instance, let's say this one is C, that one's D. If that's C, tan C, the tangent of that angle is 4/3. What's the top represent? Yeah. This is the opposite. The bottom is adjacent. How do we know that? Because TOA, right? Tangent is equal to opposite over adjacent. That means the opposite of C, which is DE, is 4. And the adjacent of C, which is CE, is 3. How come DC is not adjacent? That's the hypotenuse, yes. Okay? There we've got it. Write your answer as a fraction. Find the tangent of D. Tan, past tense, right there, tan. Let me miss that, Joe. That's okay. Tan D is equal to, yeah, 3/4. Good. So we switch it up and we start looking at this angle then. That and that would make that opposite and that adjacent. 3/4. The first step is to get your picture drawn. Okay, any questions? All right now everyone rate themselves 1 to 5. 5, you're there. 1, you're not at all. You're like, I don't know where I'm at. Okay. You can't go 0.5, so we're not taking fingers off. Okay. Number 8. Let's give it a go. Do your bestest. Get it, lucky dog.
Can I bring it to school?
Your dog? I'd love you to bring it to school, but they frown upon that.
Crash is so nice. Oh, you would love him. He's so fluffy and calm. He just sit here and beg me for food, and I just pet him, you know. And then he probably just lay it under the chair.
I just said that.
That would be really nice.
He's on the other hand be running around the school, so just watch out.
They might bite someone. We don't want that.
No, she doesn't bite. No. My dog bites.
What?
You have a dog?
Oh goodness.
I have a blue heeler. Oh, you do? At your house? Yeah.
Okay, how'd we do?
Good.
Oh, okay.
I did goody.
Wants to walk the width of a river from point A to 100 feet. Measures the angle from this point to be 40. What type of angle is this? From the horizon, it is acute. From a horizontal, it's an angle of?
Elevation.
Yeah, on this picture, it's the angle of elevation. Technically, it wouldn't actually be in real life, right? Because you're not elevating anywhere. But I just wanted you to look at that. Look at it like that. Okay? All right. Angle of elevation, I just wanted to reference it, even though that's not what you're looking at. No, we will. You'll see it, Jen, if you... You'll see it down here on number 9. I was just trying to foreshadow.
But we got the same answer.
What?
Yeah.
Got the same thing? Did you put it this way?
Yeah. No, we put
I'll come over and...
No, we put 40 degrees at point C.
Oh, at C?
Yeah, and then we did 100 over W plus 10 and we...
Let me come over and look at it. Okay, I'll be around. Check out letter B, please. Letter B. How does it change? Yeah, it's now instead of tan 40, it's tan 51 is equal to W over 100. So we get 100 tan 51 is equal to W. So W is good. And so how has the width changed? Well, it's went from 89.5 or 83.9 to 123.5, which is about 39.6 feet. Holy cow, man. That's a big change. some erosion. Yeah, I'll get you an assignment for sure, man. I'm about to. Okay? Before we do that, I'm going to give you number 9, and while I'm handing out the assignment, you guys try number 9. Make sure you draw the picture. Okay, so on number 9, it says angle of elevation. You must start with that horizontal line, and then from there, elevate 18 degrees. Boy flies a kite at angle of elevation. There's our cool kite. Okay, 18 degrees. The kite reaches the maximum height at 300 feet away from the boy. That means this is 300. What is the maximum height of the kite? Well, that's our height. It's a right angle distance. Okay, so if I'm trying to figure that out, I need to deal with these two sides right here. This is my adjacent. This one's my opposite. I know that looks like hypotenuse there, but that's our height. So we have tangent of 18 is equal to opposite over adjacent. Remember, h is our height. Okay? So if you want to use a different variable, maybe to make it less confusing, call it x. Okay, so that would be 300 tan 18 equals x, or x is approximately 97, oops, not 0.97, 9.7, 97 point, is it 8 or 5? I think it's 5, yeah. Okay. 97.5 feet. Alrighty. We're out of time, so number 10, I'll leave to you. You guys can do that one on your own. I'll put up the answer a little later if you'd like to see it. Okay? It's a tougher problem. It's kind of a challenge one. It's a good one. Hey, for those of you who wanted to see how to do number 10, there is the work for it and the solution. Great day.